final few steps, and then show you how to get your calculator to check this thing. Your calculator is up to this task. So maybe you have different steps than me. Me, I underline all the x terms, 2x and 3x. Those are the ones I want to collect. 2x is staying on its own side. It's staying on the left side, so it stays over here. But 3x is coming over, so it's got to switch operations. It was 3x, now it's subtract 3x. If there were other types of terms, then I'd use my other lightning underlining from there, and I'd sort with like that. But there's only the constants now. Negative 3 staying on its side. Negative 2 comes over, and plus 42 comes over. Plus 2, it was adding 2 over here. Now it's subtracting 2, and it moves over here. Subtract 42, now it becomes add 42. And I get negative x on this side when I collect those terms. And I get negative 3 minus 2, which is negative 5, plus 42, which is 37. Negative x equals 37. That's a little tricky, actually. I'm going to close this window, not because of the noise. Because I think we've done all we can do with getting cool air from outside here. Oh, that's better. Woo! Negative x is 37. It's actually a weird, easy situation. But how do I get out of it? How do I finish it?
You currently just reverse it.
Yeah, right. Some people will just look at that and they'll just go,
37.
x has got to be negative 37. If it bothers you, you could do, you could divide both sides by negative 1. If that makes you feel better. So it's a situation that's like really weird. It's weirdly difficult and easy at the same time. So x equals negative 37 is my guess as to what this thing is. But let's say you're feeling nervous on a test. You're like, you could go back and check all the steps. You could, but your awesome calculator becomes a weapon here now. And I've got one on the screen here I'll bring up. Do I? There it is. Where is it? My active board's being a little wonky today. I might have to go to the desk. And it says the left side is x plus 1 over 3 minus 7. I can type that in exactly on a good calculator. I can go fraction, and I can go negative 30. Sorry, I'm going to do it on the computer because the active board and the calculator are not working very well together today. So I'm going to go negative 37 plus 1 over 3 minus 7. That's the left-hand side as I see it. Negative 37 plus 1 minus 6 equals negative 19. So if x is negative 37, then the left side, did your teacher previous teacher just use ls for left side? Yeah, you don't have to write out left side every time. I already forget. What did I get? Negative 19. Right side. Now, again, this is why we get a cool calculator, because it makes your life easier. X minus 1 over 2. So now I'm going to go negative 37 in a fraction. Negative 37 minus 1 over 2. And what am I hoping for? Negative 19. Negative 19 would make me happy. Now, listen, before I press the button. If it comes up negative 19, do you see how much time that saved you on the test? Some people run out of time on tests, and this is one of the little tricks to save yourself some time. If it comes up negative 19, I can mark this right myself. Mr. Todd, you don't got to mark it. I'm going to mark it right. Yes? If it's wrong, people make a mistake at that point. They panic. They start checking this over, and they waste 5 or 8 minutes trying to find a mistake. Finding mistakes is difficult, folks. Wow. It is hard. Don't do it. Go finish the rest of the test. Just put a little X beside it yourself, a little note to yourself, and go, apparently that's wrong. But let's say it is wrong. Let's say you missed a negative here, made a little mistake. When I go to mark it, and you made one little mistake, and this is out of like 5 marks, how many marks do you think I would give you? Like future teachers, how many marks would you give for one little negative mistake? Some teachers are cruel. I'm not. If it's one little mistake, it's going to be 4.5 out of 5. That's not, you can't waste 5 minutes on a test chasing half a mark. Can't do it. You don't have time for it. Move on and come back to it at the end. And don't get upset about it. Don't come and say, number 7 wouldn't work out. Meanwhile, you got a whole page of algebra. It'll be all I can do not to laugh at you. If you come and say, it's not the right answer. I'm like, yeah, but look it. You got most of the marks. Everything's fine. It's the ones that are blank that should worry you. Those are the questions that are going to get you. Not a page of algebra. A page of algebra, you're like, I did pretty good. It'd be all right. Okay. Is it right? Let's hope it after all that. It's right. -19. Yeah, -19. Okay. Good stuff? Yeah, good stuff. Good strategies. Good strategies for high-end algebra. Then once you finish the rest of the test, and there's still time left, you can come back and go, okay, let's see if I can find it here. Because it's difficult to do. It's very difficult to do. Most times, beginner algebra people like you have to redo the question on a separate page. It's the only way you're going to find the error. Because it all looks right when you look it over. It's very difficult to find those errors. All right, we carry on. Oh, I left extra space. Oh, I thought I was going to need extra space for a check. I didn't. Okay, some review of the exponent laws. Hopefully the exponent laws, once I explain them again, you're like, okay, I get that now. Because you're supposed to have seen it in grade 9, but grade 10 doesn't do a great job of reviewing exponent laws. They come up from time to time, but you don't see them that much. So get this part down. Multiplication law. The first one's the multiplication law.
Sorry for the interruption. Could all students with the last names that start with M and N please go to the gym now for pictures?
It's weird. That's all one row went. What are the chances of that? Oh, they didn't check their names. Maybe they're lying. Okay. Here's what I'm going to do. I'm going to do what your grade 9 teacher with time was supposed to do. I'm going to show you something and try and make it so that the multiplication law, it sounds like some mathematical powerhouse thing. Multiplication law. No. It's more like multiplication shortcut. Here's something to make your life a lot easier. I'll do a fairly big one. Say you get given a question that's 3 to the power of 5 multiplied by 3 to the power of 9, which is a lot like the question I've got coming up. But I'm going to do it in long form, the way you should have done it in grade 8 or grade 9 the first few times until you got annoyed. 3 to the power of 5 is 3 times 3 times 3 times 3 times 3. Whew. 5 3s multiplied together. And that's multiplied by 9 more 3s multiplied together. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I really hope you're like, are you out of your mind? Don't do that. But just in case, I want to demystify the multiplication law, where you go, well, duh. How many 3s is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 3s. Are you surprised that there was 14 3s there? What's the shortcut? I almost said trick, and I don't want to use the word trick, because trick makes it like there's something mysterious going on. There are math tricks in this world. There's plenty of math tricks that are like, I don't know why it works, but do this. This isn't a trick. It's a shortcut. What's going on? Just add the exponents. If you're multiplying 3 9 times, and then 5 more times, that's a total of 14 times. So here's the law in a fancy form. If you've got, I don't know if that's going to be big enough. I'm not too happy with the size of that. Let me move the box and then I'll zoom in. Zoom. 150? 200? Not bad. I'm going to write it off beside. I don't like how that's coming out. Okay, so here we go. A to the m, which means anything. Any number you want as the base. Whatever number you use there. And if you're multiplying that by a to the n. Now there's some stuff going on here. The first thing is these bases have to be the same. This only works if the base is the same. Somebody raises their hand and goes, what if the bases aren't the same? Then you can't do anything. I don't have something saved up next grade or something like that. If the bases aren't the same, this does not work at all. The bases are often the same. You go to biology or chemistry class, something like that, Often the two things you're working with are all of the same base, and that's how this happens to work a lot of the times. So it's not a random thing that the same base happens a lot. Yeah. If you're doing a to the m times a to the n, you just go a to the m plus n. Is this better than that? No. This is way better, right? This shows what's going on. Most people, when they see this, go, I know what's going on. But this is handy, convenient, and looks great on your study page. You put that on your study page, and you remind yourself, oh yeah, same base, add the exponents when you're multiplying, yeah? Is it good? Is it okay? Okay, I need to tell you, by grade 11, you're excellent poker players. I can't tell what cards you have, most of you, when I'm looking at you. I go, everything okay? Blank face. That's not the relationship we need to have. Lay it on me. You need to, yeah, it's good. Then I know. It's not about making me feel good. It's about then I can go, oh, I can move on. I don't have to over-explain. You can frown. You can be like, and then I'll just look at you and I see someone frown. I'm like, oh, more. And I'll give a little more. I'll explain it a little more. I don't want to bore you, but I don't want to be too fast either. Yeah? So you can lay it on me with just a frown. Or you can just shake your head like, Or raise your hand and just tell me where it's at. Here's the part I don't get, you say. And I go, oh, okay. And I re-explain. Okay? I think that's my greatest strength. The ability to re-explain. I'll give what I think is the best version. Then you tell me and I'll fix it. But you all play poker. I look out and you're like, just acting like it's all perfect. All right, well, if it's so perfect then, 3 to the 5 times 3 to the 4, how could I simplify that? 3 to the 9. I'm going to write the extra step because I'm the teacher, and I'm supposed to write great notes. 3 to the 5 plus 4 equals 3 to the 9. But if you're at the point where it's like, yeah, I'll just write the answer. Thank you very much for the extra step, but I got it. Thank you. The only way I could think of to be tricky is to do this one. X squared times x cubed times x. If I put those all together, what exponent do I put on x? Just think a little bit. 6. What exponent is on the x when we don't write an exponent? 1. We don't want to have to write 1 on top of every number that happens to be exponent 1. Nobody would have got out of kindergarten if we did that. 1 to the 1, 2 to the 1, 3 to the 1. Nobody talks like that. Yeah. And this one, it works no matter what the number is. If it's a 3, if it's an x and we don't know what the number is, or if it's a 2.57, you can just add the exponents. Okay? Does that ring a bell big time? I hope it does. And don't be surprised if that happens. Don't give me too much credit. When I re-explain something you saw in a previous grade and you go, I get that now, Mr. Todd's awesome. I am awesome. But when I'm re-explaining something, something happens in your brain, you're like, you're hanging a hat on something that's already there, you're like, oh, now I get that. And learn that lesson from math, that sometimes you watch my lesson, you're like, I didn't get what he said at all today. You turn the video on, you watch it again, you're like, now I get it. 2 times through is huge. I do it all the time. This is the math I work on at home. Sometimes I'm like, what? Go back 5 pages, read it again. I'm like, okay, now I get it. What do I, back?
Yeah, on C, what's the exponent of the first bracket?
7, and then 4. I'm going to make them bigger for you. What's fun about this course is, because I haven't taught this in a while, I'm remaking all these resources. I'm updating them and changing them so I can fix them. My advanced function stuff, if you have me for advanced functions next semester, it's already, I've used it 20 times, so it's all fixed. But this is fun for me because I get to rebuild stuff. Yeah. Okay, it's good. Yeah. Division law. Well, this is not too exciting after seeing that one. But I'll do a motivating example here. Division law, I'll do 3 to the 9 over 3 to the 4. Future teachers, 3 is a good number to work with because it's a prime number. If you use 2 here, hi there, things can get a little confusing. Well, if you use 2 there, hold on. Did we steal your desk? I'm ready. We'll put you here for now, but we'll get you in a row again soon, okay? It's good. Oh, good. And there's one back there. Good. We will move things around. This happens in the first week. We get added people in my class. It's wonderful. Welcome. Everything's okay? Warm, eh? Yeah. If your pictures are done in my class, you can get rid of that vest. Not necessary. I don't even understand it. Anyways, I lost my pen. Who took my pen? Okay, here it is. This is actually pretty fun. I like what happens here. 3 to the 9 over 3 to the 4. I'll do the long version of it one more time in your life, hopefully. This is the last time. You're going to write it all out. Numerator. Three times 3 times 3 times 3. 4 of them now. 5, 6. I wish I chose a smaller number. 3 to the 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and the bottom is 3 times 3 times 3 times 3. And let's get distracted for a second, because I want to talk a lot about cancellation. People throw that word around all the time. I want to talk about cancellation. I'm going to have this exact speech a bunch of times this year. But it's worth covering. This might be the best thing I say today. So if you've drifted off to sleep, or if you're dreaming about your lunch, or the heat's getting to you, now's the time to pay attention. This is good stuff, what I'm about to tell you. Let's pretend we went on a field trip to a grade 5 class. I think grade 5 would be the right level where this would work good. And I show up in grade 5, and I write this question on the board. I say, put your calculators away. And I want you to do this question in your head, mental math. And I went like this. I have lost most of them already. Most of them, like, in my head, 3 digits. They've learned the 3-digit stupid algorithm, line them up, that thing. Yeah? Well, as soon as I write that, like, you want me to do this in my head? I'm like, yeah, watch this. Their heads will explode. They're going to be like, you're out of your mind. I can't do it. 1 or 2 really will be like, 9, 10, and they're doing that. I'm like, you're missing it. If you're doing that, you're missing it. Why is this particular question so unbelievably easy? Plus 792, minus 792. So nice. 235. You see, this whole game so far has been about inverse operations. We taught you addition. The very next year, we teach you subtraction. Teach you multiplication, we teach you division. The story's not over yet. So if you think it's like, oh, I totally get that. No, we're not done yet. Sine, sine inverse, exponential, log. There's a lot more to go yet. We got lots of stuff to talk about. But here's the idea. So here is the idea for you today. Watch this one. Here's one for you. 1,432 times 755 divided by 755. 1,432. Because those two operations cancel out. So my sentence, if you do an operation and then do the opposite operation, those two cancel out and you end up back where you started. Well, that's what happens in the division law. I've got a whole bunch of multiplying by 3's and then I got a whole bunch of dividing by 3's. Now, if your brain just hitched when I said that, you're like, what do you mean they're divided by 3's? They're multiplying. I'm like, no, they're all in the denominator. Everything down there is being divided. You can multiply them together if you want, but in the end, you're dividing by all those 3's. So I've got a whole bunch of cancellation, and this part's fun. Cancel, cancel. That pair cancels. Cancel, cancel. That pair cancels. Cancel, cancel. Cancel, cancel. 4 of the 3's cancel, and then I'm left with how many 3's? 1, 2, 3, 4, 5.
Could all students with the last name that start with O, P,
good?
and Q please go to the gym
I threw you a 4th one because just in case somebody forgets one on the shelf, right?
Somebody new every day. I don't
Now you do have a teacher book. You don't have the specialty teacher book? Oh, order it, buddy.
No, I have it. It's gone to a kid.
Oh, so you're going to give
I'm
that to
gonna
the
trade
kid,
it out.
get the
Yeah,
teacher
but
book
it
back.
just-
Okay, good.
I got 34 and 31. No, but 32. It's
Yeah.
we're swimming.
Awesome. Great stuff. What's the trick? It's not a trick. There are math tricks. I'll show you lots of math tricks. This is not a trick. What's the shortcut here? Hopefully you're out there going, you wasted a lot of our time doing that. Do you know the shortcut here? Yeah, if it's multiplying is adding, then dividing would be subtracting because they're both inverses, eh? There's something locking together about all this stuff. So here's the fancy version of the law, which if you can't read it, I'll zoom it in just a second here. Oh. 400% zoom. Whoa! That's some serious zoom. That's too much zoom. 200% zoom. I'll write it again over here like I did last time, just in case it's not big enough. A to the m divided by a to the n has to be the same base. If it's not the same base, we can't do anything. I don't have another trick saved up. It's like, well, if it's different bases, you do this. No. This only works for same base, but it often will be same base. If you're doing some chemistry stuff or some biology stuff, computer stuff, you're probably working all on the same base, and this will happen a lot. You subtract the exponents, but there's a little rule here. As long as a is not 0, can't divide by 0, and we'll talk a lot about that as we go along, but can't divide by 0. There's a day coming up where we're going to do some stuff. We're going to talk about dividing by 0 and why it's such a problem, okay? But a cannot be 0. You cannot divide by 0. So this doesn't work if the denominator's 0. Nothing works. So then these are supposed to be easy after you have that rule in your back pocket. And incidentally, I have a solution for those of you who think you blank on tests. You go, you know what, I do all my homework, but I just blank on tests. I know what's wrong, and I will help you fix it along the way. So if you're a test blanker, we're going to fix the problem. One of the ways we fix test blanking is take the notes. When I'm writing, you're writing. And the second is we're going to come up with study sheets that allow us to make sure that things don't blank out on you. This would go on the study sheet. That right there. So the day before, you're getting those things entrenched so they don't blank out when you show up at the test. 7 to the 11 divided by 7 to the 4, 7 to the 11 minus 4. 11 minus 4. I said out loud 4 and wrote 7. Equals 7 to the 7. Negative 2 to the 18 divided by negative 2 to the 8 is negative 2 to the 18 minus 8, which is negative 2 to the 10. Can we do better than that? Can we punch negative 2 to the 10 in our calculator and get something simpler? Well, maybe, but exponents are nice. I think as we move forward, when something's got exponent on it, just leave it the way it is. It's nicely done the way it is. And k to the 12 divided by k to the 7 is k to the 5. And if you think this is overkill, you're going to see it's not. But I should mention, k can't be 0. Yeah? So that's something we're going to learn in this chapter. It's like, better mention what k can't be. It's really going to matter. K can't be 0. This doesn't work if k is 0. Any questions about those three? I did them pretty quick. I felt like that maybe after seeing the multiplication law, division law, I was like, okay, I got it. Divide. Question?
I kind of forget, but like, if like it's negative 2 to like the power of like 5 or something, and you like express it like as like you want to get a number out of it, you know, you do negative 2 to the power of 5. I forget if like how to tell if it comes out as like a positive or something.
That's a good question. Negative 2 to the power of 5 would be negative 2 times negative 2 times negative 2 times negative 2 times negative 2. And let's just talk about whether this is going to come out to be positive or negative for a second. Those two multiply together to be a positive. Those two multiply together to be a positive. Then there's one negative left over. So this thing's going to be negative something.
What if there's 6?
Perfect question. Even, yeah.
It's not on anymore. Whose birthday is it?
Whose birthday is it?
Pairs of negatives, pairs of negatives, pairs of negatives. So that's positive.
So if it's even, it's positive?
Perfect. And do you see how you asked me, and you should ask me. They're paying me to be here. But It doesn't take long to go, wait a minute, how does this work again? And write something out. That's why I did those examples where I wrote them out. I'm like, if we forget the quotient law or the division law, write it out real quick and go, well, how does this work again? Okay, subtraction. Okay, odd, even. Yeah. Mr. Duff, how are you?
I am good. Meg's birthday. Happy birthday.
Happy birthday, Maggie.
Say, Claus.
Happy birthday, Maggie.
How's math going today?
Fabulous. Temperature almost livable today, almost.
If it gets too hot, they are welcome to take the vest off in class.
I mentioned that, they didn't go for it. I said the ones that were done their picture could, but they're too cool. Well,
Yes, if it's an odd number, it's going to work out. It stays off. If it's even exponent, well, then there's even numbers, so they cancel each other out. Awesome. Math is like magic.
it's like magic.
Well, have a good day, everyone.
You too.
If you're running out of steam, power of a power law, and then 3 examples. That's all I got left, okay? So zone back in, shake the webs out, and go again, yeah? Power of a power. Here's the situation for power of power. What we've got is 3, an exponent with an exponent. This happens a lot as well. In situations where we're working with applications, we'll get a power with another power. Now watch this. You don't want to have to write this out very often. But seeing it once is important to see why this happens like this. So the inside is 3 squared. So that's 3 times 3. But I got to do that 4 times. You're like, you're not really going to write this out, are you? Yeah. I want you to see it one time so you know that this is not magic. There is math that is like magic, and there's math that has tricks. This isn't a trick. This is just a shortcut to go, I don't want to have to do this. Every time I run into a power of a power. Well, maybe you could in your head go, what would happen here? I'd have 2 3s. I'd have it 4 times. There'd be 2 groups of 4. I'd end up with 3 to the power of 8. 1, 2, 3, 4, 5, 6, 7, 8. Do you have a shortcut? Not a trick. A shortcut to get to the end here? Yeah. So if whatever base, now it's just one base. If you have a base, exponent to another exponent, you can just multiply the exponents. Doesn't that simplify things down? Here's the fancy law. This is what you write on the study page, right? You write a to the m to the n equals a to the mn. Is this better than this? No, this is way better. This shows you what's going on here. But this is a nice shortcut to put in your study page to go, okay, what if the exponent's here? Oh, a to the mn. Even better would be flashcards. Ooh, the flashcard people. You know them from a mile away. You know because you think you're smarter than they are, and they keep getting higher marks than you on everything. That's how you know flashcard people. You build a bunch of flashcards that have these on them. It makes it so you don't blank out on tests. And you can rent them out. Someone sees your pile of flashcards, especially for biology. You got a pile of biology flashcards. Somebody sees them and they're like, can I borrow these? Like, yes. You can have them for this evening for $20. And they're like, absolutely. That's how valuable flashcards are. They're good. Good stuff. All right. 5 to the power of 3 squared. Multiply the 2 exponents. And so I get 5 to the 6th. Could I do 5 to the power of 6 and find out what that is? Yes, but lots of times we like to leave it as an exponent. Isn't that tidy? 5 to the 6th. It's nice. We don't need it as a number necessarily. And even with a variable, this works. Y to the 4 to the 5, multiply the 2 exponents, and you get y to the 20. Do you have any questions on that? On a Thursday. Is it Thursday? Oh, Friday already tomorrow. Good. Friday, we'll do an extra long lesson to make sure you have lots of homework for your weekend. I never plan it like that. That was just a joke. If it works out like that, it's just random. The lessons fall where they fall. Yeah. You got a PA day like next Friday, though? Like next Friday. mysterious. These aren't the questions you got to worry about. There's the questions you got to worry about when they combine all this stuff together. So I want to show you a way to handle this situation when things get a little crazy. Some people look at this and they know exactly what to do. I'm not going to teach those people.
Sorry for the interruption. Could all students with the last names that start with R and S please go to the gym now for pictures?
This is the fastest photo day ever. It used to last all the way through lunch. Yeah? Okay. There's going to be two different lines here. I'm going to do the first line in purple. Purple is the optional line. Purple is for people who are looking at this going, I'm not quite good at these yet. People are like, I got this down pat. You can just start on the second line. Here's what you need to understand about multiplication. And I'm just teaching it to my 7 and 10-year-old now. Multiplication is a nice operation. It's commutative. You only have to learn half the multiplication tables. 5 times 7 is the same as 7 times 5. 6 times 8 is the same as 8 times 6. See, it works both ways around. And that's very friendly. And we can use that here to go 2x squared negative 5x cubed. You're looking going, I got to multiply all this stuff together. I don't even know what x is. How am I supposed to multiply it together? So here's what I do. I change the order of multiplication around. I go, okay, instead I'm going to multiply, start with the 2. Start with the 2. Then I'll do the negative 5. It's so clever. It's like, hang on. Multiply the 2 with the negative 5. Then I'll multiply the x squared. Then I'll multiply the x cubed. Please do not be shy. Do not feel you're stupid or anything like that if you write it out that way for a while. It's so good for your brain to go, hold on. Multiply these two, then multiply those two. Those of you who have this down pat, you're like, I don't need that step. I can jump all the way to here and go, okay, multiply the coefficients. Non-optional step. Multiply the coefficients, I get negative 10. And then x squared and x cubed. See, this is why this is in the exponent law part of it. That's where the exponent law part comes in. X squared times x cubed, I can add the exponent and get x to the 5th. Is okay? I'm going to write a wrong answer over here. I'll write it in red. Mostly for you, but also partially for anybody who wants to be a teacher later. I'll tell you the most common mistake that you'll see here. You'll see people write this. Can you see what happened?
Instead of multiplying.
Yeah, this was multiplication. And so their brain did this. Brain did a lot of good stuff. This is a really good answer. Somebody who writes this, I'm not worried about them at all. I'm like, it's okay. Just think for a second. This is all multiplication. So x squared, x cubed, their brain goes, oh, add. Right, I remember, add. And they write x to the 5 and they go, that's right. And they go, oh, add 2 and negative 5. Like, whoa. The exponent laws are for things with exponents on them. Regular numbers, you still multiply them like you always did. But your brain can do that, and you can't get upset with yourself when that happens when you're learning stuff. And then it ends up people going, oh, I'm not good at math. Like, oh, no, you're just learning math is what's happening. We haven't found out if you're good at math yet. We got a long way to go to figure that out, all right? So don't get upset when these little errors happen. Don't get all mad at yourself and say, oh, this is why I hate math. Like, oh, I did good. I got the x to the 5th right. Now I just got to get my brain to finish the deal. Optional step here. Some people will find this question very easy, the way their brain works. But here's the optional step. If you have trouble with these at all, do not be embarrassed. Do not be sad if you have to write it out this way. 36 m to the 5 n to the 11th, negative 6 m cubed n 7th. I know what happens with this question when you read it. Your brain just locks. It just goes, It looks like, okay, every day at lunch in my life, I got fed alphagettis. Do you know what alphagettis is? It's a bowl of horrific slop sauce with these lowest quality noodles on the planet, but they're all letters and numbers. Now, I don't want to gross you out, but one time, I won't finish the story, you get the story. One time my mom gave me alphagettis and I had the flu. Of all the things in the world, you don't want to throw up. alpha-Gettys. But that's what this looks like, right? It looks like someone puked alpha-Gettys all over the page. And your brain just locks up. Here, I'm here to help. Instead of all that, just look at that part. And if you don't want to have to do the extra writing, just put your hand over there and go, oh, 36 over negative 6. Well, I guess I can do that. I guess I'm okay, 36 over negative 6. And so write it like that. Write it as 36 over negative 6 as sort of a, not a separate fraction, but you're sort of separating that part of it. 36 over negative 6. Just deal with the coefficients. Then, this one, m to the 5th over m cubed, and n to the power of 11 over n to the power of 7. And I'm just doing that to think. So that it's not a big chunk of alpha-Gettys anymore. I can look at it and know what's going on. Because 36 over negative 6, hopefully, oh, non-optional step, hopefully you've got that. And if you don't, come on, it's time. Let's get some of the multiplication tables down. Let's get up to the 6s at least. Yeah? Let's use September and get up to the 6s at least. 36 over negative 6 is negative 6. m5 over m cubed. There's the exponent law, because those are powers now. Once they're powers, the exponent laws kick in, and so I subtract the exponents, and then I subtract the exponents. What do you suppose, future teachers, would be the most common error here? It's not with the variables. It's not with the variables. Most people get this right. Ooh, I'll put a big X there going, that's wrong. What do you think that a lot of people write as the coefficient once their brain starts thinking about exponent laws? What's that? 30, yeah. I see 30 a lot, and I see, weirdly, 42 a lot, because they go 36 subtract negative 6 or something like that. But those usually what happens, because your brain gets thinking about exponent laws. So you really have to go like this on these questions, just go. Maybe your brain can do it. I think that's what people who are good at these, that's what they can do. Their brain can do that for them. Maybe your hand has to do it. For you. Here you go. Oh, just covered up. Question. Question. We're good? Wrong. Make sure that's on there. Wrong. Yeah. More questions? Don't feel weird about writing these out like this. Because what will happen, let's say there's 14 questions in the homework. And the first 2 you have to write out like this. By about the third, you're like, okay, I got it now. And then you won't have to write it out like that all the time because you did the first couple of times. So it's worth it. It's worth the effort. Is there one left? My brain tells me there's one left. Oh yeah, C. All right. Let's not wait around till tonight to find out you don't have this down pat. I did one with multiplication. I did one with division. Here's one with multiplication, then division. That's my hint. You try it. Give it a try right now. I'll do attendance. And then we'll take it up in how much time? 3 minutes. I'm going to give you 3 whole minutes to really think it over and try it out. Video people, you can fast forward for 3 minutes for the take-up. Or you should try it yourself, is what you should do. Question, yes? Oh yeah, you want more zooming. Here, I'll give you lots of zoom until I take it up. Sorry, my active board is being completely hilarious today. Now I need to freeze that. Did the seating plan make the rounds? I'll use it for attendance today, but then I'll get to work. So if I awkwardly stare at you the next couple of days, I'm not up to anything. I'm just trying to remember the names. Izzy. Need more time? All right, you've taken your shot. You've taken your shot. I'll do the first step and then you argue. Did you do that as your first step? Yeah. That's the way I saw it. I dealt with the top first. I think that's a good strategy with fractions. Get the top figured out, then get the bottom figured out. I tried to write it cleverly too. Not in separate fractions, but look at it all lined up. Now my brain can handle it. Now my brain can see what's going on. I'll write the first two, which I think most people will get, but there might be a mistake in the last one. -30 over -3. You got to reset your brain after you finish these two. Because you're thinking subtract exponents. It's easy to try and subtract these, but it's not, it's division. Those are just regular numbers. How'd you do? Okay, we're not on about it today, but very soon we're going to have to mention. We're going to have to say, this only works if x isn't 0 and if y isn't 0. So this is not today's lesson. I just mentioned, in case you're right with me, you might be like, hey, wait a minute. There's a rule here on dividing by 0. And I haven't talked about dividing by 0 yet. And I will. I'm really going to talk about dividing by 0 when it's lessons. And you don't have to write it tonight, but just to mention, if you see that, it's because there can't be stuff in the bottom that's 0. That is not allowed. Not allowed. Not like, oh, we'll wait until Mr. Todd explains how to divide by 0, or not, oh, we're waiting for some Einstein of the new generation to figure it out. Dividing by 0 is out. You're not allowed to do that. Any questions there?